Hello, my name is Sherina Sarah Hamis, and this is my assignment in Intro to Computing lecture under Sir Mark Flores. So our assignment is to convert these 5 numbers according to the required number system equivalent. So for number 1, we have 2BC116 that with a subscript of 16 that we will convert to a number with a subscript of 8. So 16 basically means hexadecimal, so we will convert it to a number with a subscript of 8, which is octal. So first we will have to get the decimal equivalent of these numbers. So for 2 we have 2, for B we have 11, because in hexadecimal number system, A is equals to 10, B is equals to 11, C is equals to 12, D 13, E 14, and F is equals to 15. So B is equals to 11. And then we have C, which is equals to 12, and 1, of course, equals to 1. And then we will convert this number to its binary equivalent. So to get the binary equivalent of these decimal numbers, we will use the bit number systems. I will use a table to show it clearly. So we have 8, 4, 2, 1. And then for 2, we will place 1 under 2 because we will add the numbers, this 8, 4, 2, 1. So since we only have 2, and then we will add the 0, 0, 0, so that's equals to 2. So we have 0, 0, 1, 0 for number 2, and then for number 11, so 11 is the sum of 8, 2, and 1. So we will place 1 on 8, 1 on 2, and 1 on 1. And for the number that we didn't use, we will place 0. So 11 is equals to 1, 0, 1, 1. So for number 12, it's the sum of 8 and 4. So 8 plus 4 is 12. So we will place 1 on 8 and 1 on 4. And for the rest of the numbers that we didn't use, we will place 0, 0. So that's 1, 1, 0, 0. And for number 1, of course, we will only use the 1. So we'll place 1 on it, and the rest 0, 0, 0. So that's 0, 0, 0, 1. So these numbers are grouped into 4. Now we will have to group them into groups of 3. So we have 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, and 0, 1, 0. And we can remove this 0 here. Okay, so since we have groups of 3, we will use the 4, 2, 1 bits number of system. So we will multiply and add these numbers. So if we have 0, 1, 0, we will multiply 0 times 4, 1 times 2, and 0 times 1. So that's 0 plus 2 plus 0. So that's just equals to 2. So we have 0, 1, 0 is equals to 2. And then we have 1, 0, 1. So 4 times 1 is 4. 2 times 0 is 0. And 1 times 1 is 1. So that's 4 plus 0 plus 1, so equals to 5, or simply 4 plus 1. And then we have 1, 1, 1. So 1, 1, 1, multiply each on 4 to 1, so that's 4 plus 2 plus 1 equals to 7. And for 0, 0, 0, of course, that's automatically equal to 0, and then 0, 0, 1, so that's 1 times 1, so it's equals to 1. So we have 2, 5, 7, 0, 1 octal number. Okay, so the final answer for number 1 is 2b C1 base 16 equals to 25701 base 8. Okay, so let's erase this for a while. Okay, now let's proceed to number 2. So in number 2, we have 110010 subscript 2, and we will convert it to a number with a subscript of 16. So 2 basically represents binary, and just like in number 1, 16 represents hexa. So this is a binary to hexadecimal conversion. To convert binary to hexadecimal and vice versa, that's hexadecimal to binary, there is a shortcut method that we can use. If we memorize this table, it is very easy. We just have to look for its equivalent. So first, we have to group the binary numbers into 4. So in number 1, we group the binary numbers into 3 because we are converting it to octal number system. Now we are converting it to hexadecimal number system. So we will group them into groups of 4. So that would be 0010, and here we will add 00, so that would be 0011. So just by looking at the table, we can see that 0010 binary number is equals to 2 hexadecimal, and 0011 is equals to 3. So we already have our answer. So 110010 base 2 is equals to 32 base 16. But there is also another way if we don't have our table or we don't memorize the table. Just like in number 1, we can use the bit number system. So if we have 8421, we will multiply the numbers or the digits of the binary. So that's 0010. So 0 times 8 equals 0, 0 times 4 equals 0, 1 times 2 equals 2, and 0 times 1 equals 0. And then we will sum them up. So 0 plus 0 plus 2 plus 0 is 2. So that's 2, and then for 0011, multiply 0 by 8, and 0 by 4, and 1 by 2, and 1 by 1. Then sum them up. We have 0 plus 0 plus 1, by plus 2 and plus 1. So we have 3. So we have the same answer. So the final answer for number 2 is 110010 base 2 is equals to 32 base 16. Now let's proceed to number 3. Okay, so we have the given 175 with a subscript of 8, and we are going to convert it to a number with a subscript of 10. Okay, so base 8 represents the octal number, and base 10 represents decimal number. So this is a octal to decimal conversion. To convert octal to decimal, we will get the sum product of each digit with the decreasing power of 8 for octal. So the solution will be 1 times 8 raised to the power of 2 plus 7 times 8 raised to 1 plus 5 times 8 raised to 0. So that's 64 plus 56 plus 5. And the final answer is 125. So for number 3, we have 175 base 8 is equals to 125 base 10. Now let's proceed to number 4. We have 345 base 10. So that's decimal, and we will convert it to a number base in 16. So that's hexadecimal. So this is a decimal to hexadecimal conversion. To solve this, we can use a table. So we can say here is the operation, and then the output and the remainder. So we will first divide the 346 by 16. So we have 21.5625, and then we will get the whole number, which is 21, as the output. And to get the remainder, we will multiply the decimal numbers. That's 56252 16. So 16 times 0.5621 is equals to 9. And then we will divide again the output, which is 21, by 16. So 21 divided by 16 is 1.3125. So we will get the whole number 1. We will place it in the output. And to get the remainder, we will multiply 0.3125 by 16 again. So that's equals to 5. So as long as the output is not equals to 0, we will still divide it by 16. So 1 divided by 16 is 0.0625. So now our output is 0. So to get the remainder, we will multiply 0.0625 by 16, and we have 1. So 1 here is the least significant digit, and 9 is the most significant digit. So we will read this from the bottom to top. So that would be 159. So the final answer is 345 base 10 is equals to 159 base 16. Now let's proceed to number 5. So our given is 25 base 10. So that's decimal number, and we will convert it to a number base in 2. So that's binary. So this is a decimal to binary conversion. So just like in number 4, we will use the division method, but this time we will divide the numbers by 2 since we are converting it to a binary number. In number 4, we were converting it to hexadecimal. That's why we use 16. So again, let's make a table. So here is our operations, our output, and the remainder. So to begin, let's divide 25 by 2. So we have 12.53125. So our output is 12, and to get the remainder, we will multiply 0.53125 by 2. So we have exactly 1, and then we will again divide the output, which is 12 by 2. We have 6. Exactly 6, so the remainder is 0, and then 6 divided by 2 is exactly 3, so the remainder again is 0, and then we will divide 3 by 2 again, so we have 1.5. So our output is the whole number, which is 1, and then we will multiply 0.5 to get the remainder, so that is 1. So as long as the output is not 0, we will still divide it into 2. So 1 divided by 2 is 0.5. So the whole number or the output is 0, and multiply 0.5 by 2. So that's a remainder 1. So here the least significant digit is 1 at the bottom, and the most significant digit at the top also is 1. So we will read it again from bottom to top. So it's 11001. So the final answer for number 5 is 25 base 10 equals to 11001 base 2.